Hello, good evening, everyone. So please, we'll start by 6:05. Let's wait for others to join us and see how many we are by 6:05. By 6:05, we're going to start, please. Thank you. Okay, so good evening, everybody. Good evening once again, and welcome to today's session. So now the problem is, I'm trying to come in using my laptop, but I'm facing the same challenge I faced last week. So I need someone again to help us out, and I'll send the slides to our Discord channel, and someone can help us out with the presentation. Why I see how I can join in with my laptop. So I'll send it right now to our channel, and someone should help us out in projecting using his or her laptop like we did last week. Thank you. Okay, so it has been sent to Discord channel. Could someone please help me with the presentation? Why I see how I can still join in with my laptop. Then after that, we'll get back to. I'll continue from there. Please, do we have anyone willing to help us out?
Yeah, I'll do it. I'm trying to switch to my system too.
All right, thank you. Please, how is it going, Ibrahim?
I'm almost there. I'm coming.
All right. Ugh, my system is so slow.
Okay, it's ready now. Hello? Hello, can you hear me?
Yes, we can, Ibrahim. What to start with? Because I can't see your screen. Oh, okay. Still need to put my. Oh, okay, thank you. Thank you. So I guess we'll have to start. Gosh, I really need my please be patient with me a bit. I'm trying to set something up here. Okay, hello. Can you hear me? Thank you.
Yes.
Thank you very much. So my setup is fine. Thank you. So, Ibrahim, thank you very much. I think I have to take it on here. So let's start this thing. So, first of all, welcome again to this session. I will just start simply. Having serious issues, that's not my business. So that's why we're saying by this time. I apologize for that. Next week, I endeavor that we start earlier than this time. In fact, the time we are supposed to start. So, moving forward, this week we are going to be discussing introduction to relational database and database design, which is the assignment that we have last week. Now, before that, we're going to have a recap of last week's session. Then we'll look at analyzing student mental health, which is the that we were given. We are trying 2 weeks ago on data camp. Then after that, we're going to look at If we're going to look at, we're going to go into this session, finance, which is all about relational database, the concept of relational database, drawing and effective data. Then we also, if I need someone to confirm if you can hear me, because is it fair enough? Something fair enough, please. Uh, Hold on, let me start this sound now. It's better now. This is good. Wow, maybe it's all this now. Hello, please. Can you hear me now? Is it better? Let me raise my voice a bit. Is it better now? I will say fine. Those that said it isn't clear. Can you hear me now? Okay, it was clear. Oh boy, can't hear. Is it better now? Like I raise my voice. Let me see what you hear now.
It's still rumbling somehow. It's not, but I think we should just continue. But it's not as clear as last week.
I'm actually using my headset for my laptop. And I
I
want
think
to
I
see my
think the
screen.
headset is the issue.
That
Muffled.
I've adjusted it a bit. How is it? Sounds okay. I feel the same thing.
It's quite better now.
Better or is still happening? I so technically.
Sorry, I did not
Okay.
get that. I think the headset is not really compatible with your, or maybe it's the call. I don't know. It's not clear enough.
Oh, okay. Okay. Let's see. Let's see. I need to do some things on my system. That's why okay, hold on. Let me join in with my phone. So please bear with me a bit. Let me move out of this device and look at my phone. I really hope there won't be any interference like during this thing. Okay, so how does this sound now?
Better now. It's clear now.
Hold on. Okay, so today we're going to look at the concepts of relational database and effective database design. Then we'll have question and answers before talking of assignments for next week and looking at some resources available in data camp. Now, most of these things I really want to do in my screen, but let's move on and let me see if at the end of today I can, before the end of today's class, I can still join in with my laptop. So please, next screen, please. Next slide, please. So last week we looked at a couple of things. We looked at some intermediate SQL queries. We looked at using case statements. We also looked at order of execution of some SQL queries, and also aggregate, how to use aggregate functions, then the difference between having and where, and a lot of other things. Then we looked at subqueries and CTEs. And at the end of last week's session, someone requested that we come back to CTEs again this week. So we'll be starting off with that. Now, what is a CTE? A CTE is the acronym for a common table expression. So a CTE is the acronym for common table expression. What is it used for? It can be used to as a temporary result, query result that is used within the main query. Now, CTEs, they enable us break down complex queries into simpler, smaller, and more understandable units. Now, with the use of CTEs, we can break down a very complex query into smaller parts, such that when one is reading it, when somebody else is reading our query, the person understands the function of each part of our query. So the structure, like I said last week, it starts with a with keyword, then followed by the CTE name, and after that we have the as keyword, then an open brace, followed by the query which we want the CTE to execute, then a closed brace. Then after closing the brace for the CTE, we now write our main SQL query. We now write our main SQL query. Now, using an example, we have a sales table. Next, please. Using an example, we have a sales table by our left-hand side. By the left hand of the screen, we have a sales table, and the table contains sales ID, customer ID, and amount. Now we have been asked to find the customer who has spent more than $500 in our shop from our sales table. Let us know the customers that have spent more than $500. No, now for us to do this, first of all, we need to know the amount each customer has spent. We need to know the amount each customer has spent, and after that, we will now know those who spent above $500. So using our CTE, we first of all wrote a query inside the CTE that returns the customer ID and the amount that each customer has spent as total. Now we'll use the group by to group our query, because our select statement has an aggregate function. So we use the group by to group by each customer, and the CTE will return the customer ID and the total sum of goods the customer has purchased. Now, after that, we close the CTE and then go to our main query, where we are asking that where we will request data from the CTE. Now, the data we are requesting is already that which has been generated, which is the customer ID and the total sum of what each customer has got. Now, in the main query, we will now filter to those whose value is above $500. So if we look at this, we'll find out that while the CTE gives us the total amount of goods, a customer ID, and the total amount of goods the person has bought, the main query now filters the CTE to give us those that have actually spent above $500 in our store. So that's the function of a CTE. It helps us break down complex queries into smaller, readable, and more manageable queries. Then next, please. So we are meant to work together. We are meant to solve this project together. I'm still trying here, but I think we can do it. We can actually do it together. Though I would love to have done a live demonstration, but let's see how we can work it out together. Now, in the project, analyzing students' mental health, I believe most of us have actually completed this project. So this is like a revision to see how we get to break down the question to answer each part of the question that was set for us on data camp. Now, we were given a table which contains 9 columns, and the columns are interdom, which is a description of the students. It tells us if a student is an international student or a domestic student. Then we have the Japanese CATI, which tells us the Japanese language proficiency of the students. Then the third column of the table is the English CATI, which tells us the English language proficiency of the students. Then we have the academic column, which tells us if the student is an undergraduate or a graduate level student. Then next column, we have the age of the students. Following that is the stay, which tells us the number of years the person has stayed in the country. Then we have the TODEP, which gives us the total score of depression. Then second to last, we have the TOSC, which is the total score of social connectedness. And lastly, we have TOAS column, which gives us the total score of acculturative stress. Now, going to our question, we were told to explore and analyze the students' data to see how the length of stay impacts the average mental health diagnostic scores of international students. Firstly, they said we should return a table with 9 rows and 5 columns. So I'll just like someone to tell us which keywords, which SQL keywords will answer this first question. The first requirement we are given to return a table with 9 rows and 5 columns. Which SQL keywords can return it? I don't know. Okay, Yusuf, please, let's hear you.
So we'll use the limit keyword to limit the number of rows that we want it to bring, which is 9 rows. And the number of columns will be select. We use the select to select the number of columns.
Okay, that's fine. That's good. So the first line is telling us that we'll use the select keyword and the limit keyword. The limit to get the number of rows, which is 9, as has been stated, and select to return the columns in our database. Next, columns are from our table. Next, they said the 5 columns should be aliased as stay, count, average PHQ, average SCS, and average AS in that order. So when we want to alias, which keywords do we use? You can speak up. Okay, Ayolua.
We use as. Yes.
We use the as. Okay, that's fine. So for the second line, we are making use of the as keyword to alias the columns as has been requested. Then for the third one, we're told that the average columns should contain the average of the DEP, then also the average of TOSC and the average of TOAS for each length of stay, rounded to 2 decimal places. So which keywords would help us achieve this? Hello, can someone please respond? Okay, let's hear from you again, Yusuf.
So we'll be using the round to change the decimal places to 2 decimal places. And we'll be using the average keyword to get the average of those columns.
All right, thank you. So our query on that line would look something like round, open brace, AVG, I think, yes, then open brace, the requested column, which is for the first one, TODEP, close brace, then comma 2, because we've been asked to round to 2 numbers, and then close brace. So thank you very much for that, Yusuf. Then the count int column should be the number of international students for each length of stay. Now, which keywords do we use for that? Okay, we still have Ayoluwa and Yusuf. Ayoluwa, you can take this round and let's go.
So we are going to use the count. Sorry, I can't remember the column name now. So we're going to count the length of. Sorry, please can you repeat the question?
Stay. The column is stay.
Oh, stay.
Yes.
Okay. So we are going
That's
to
the
use.
column name.
Sorry, I was thinking of something else. Please, can you repeat the question again?
Okay, I said the count int column should be the number of international students for each length of stay. Now, what keyword are we going to use in that to solve this question?
So we are going to be using we are going to be I'm thinking about the whole query. I don't know, maybe let me just say what I want to say.
Okay.
So we are going to count the length of stay, then I think I'm going to pass.
All right.
I'm going to
Thank
pass.
you. I saw Yusuf and Owosheni. Yusuf, please, let's give somebody else, Owosheni, a chance. Let him
So yes, ma'am. I
respond.
think we're going to use the count star. Then we're going to specify where Interdom is international students.
Okay.
I'm going to use count star, open bracket star, where Interdom is
Okay.
international students.
All right. So we are going to use count asterisks to count everything. Then because we are using an aggregate column, an aggregate function, which is the count, and we are all going to return the stay, which is a non-aggregated column. So we are using the count asterisks, right? Is that what you're saying?
Yes, that's what I'm saying.
Okay, so we're using the count asterisks. Now, this will help us count each, since we are going to group by stay. Using asterisks will help us count everybody or all the students in one category. So to answer that, we are using count stay. Then next, they said we should sort the results by the length of stay in descending order. So what are we using here?
So we're going to be using the order by and the descending. So we'll order by the count stay, that's stay column. Then we will order by the descending. We'll use the DESC keyword to state that we are ordering it in descending order.
Okay. Sorry for that. I'm still struggling to use my laptop and join with my phone, but it's not giving me what I want. So, okay, that's fine. Yes, we're going to use order by to order our results. Then we'll put descending to state that we are ordering in descending order. So that answers it. Okay, next so after that, then we didn't talk of the from. Which table are we using to get our query? What's the table name we're using to get our query? Okay, since no one is responding, we're getting our response from the students table. That's where we're getting that's the name of the table here. The table is the students table. And lastly, we were told that we need the information for only international students. So that means that after writing all of this, we are going to filter by international students. So our where clause will have where interdom is equal to international. So that will give us the query for, so that should give us the query for this exercise. So I want to know, while we were solving it, did anyone run into any issue or any problem in trying to understand the question that was set? If you did, just raise your hand and let's hear. Okay, so it shows that this the project was very clear and very simple. Cousin, okay, let's hear you. which challenge did you face when trying to attempt this exercise?
Okay, from what we from what we just did now, I'm trying to understand how you came about the table name that is from. Like, can you hear me?
Yes, I can.
Yeah, like how we came about the table name from student. You said the table name is from student. Then I also have problem when we are working with the filtering keyword where like I didn't get how you use it in this query. Maybe we can just come again.
Okay, now if assuming we were on the website, okay, so assuming we're on the website, we'll see that all of this information is actually there because it's stated, the name of the table is stated as students table. The name of the table is actually given. And if we read the first line of the exercise, they said explore and analyze the students' data. That students there is actually the students table. So on the website, on the site where we're told to do the project, it's written that the name of the table is the students table. Then how did we get the where? Still in this first sentence, at the end, they said to check the scores of international students present in the study. International in bold to tell you that the study and to tell you that our results should concentrate only on international students. Now, if you omit that where clause, if you omit the where filtering, your results will contain both international and domestic students, because in the description of the various fields available in that table, the first description there is inter_dom, which tells us the type of students. And in brackets, you can see that it's either international or domestic. So if we want to filter in our where clause, we need to filter by the column that tells us which type of student. And since it specifies that we need a response for only international students, we are going to filter that column, which is the interdom, on only international students. I hope that's okay, Cousin. Is that fine? Can someone hear me?
Yes,
Yes, I
madam,
can
okay.
hear
Well,
you.
I think this
Okay,
might be
okay,
the
okay.
class, but
Okay.
so
Yes, we can hear you.
yes, madam, that's fine.
All
But I
right.
want to ask something else.
Okay. I can, yes, based on this project.
Ma.
We can hear you.
Yes, we can hear you.
You said you wanted to ask another question.
Yeah. I,
Do we proceed?
yeah.
Do we, or
I was trying
maybe
to
after
ask
the class, probably
another
you
question.
ask the question.
So, at what point are we going to use the? I think you were not hearing me. I said I wanted to know when exactly. I mean, can you hear me, ma?
When we use
Hello?
what? I can hear you.
All right, ma. All right, ma. All right, ma. No problem. Okay. I said when are we meant to use the having function? Since both having and get are meant to filter data. Like I used to confuse the two of them together.
Okay, so now following this example, we use the where
Yes, ma.
because we are filtering based on a column that actually exists in the database. Sorry, on the table. We are filtering on a column which exists in the table. So that's where we use we filter using the where clause. Now, assuming we were told to filter according to a certain number, let's say, for example, after aggregating by the sum and the average, and we are told that let's look for international students whose average depression score is above 50. That's where the having comes in. Now, we will now use the having to check for those, because we'll have to use the aggregate function to check for those whose depression score is above 50. So whenever we are filtering, if we need to filter based on an aggregated value, we make use of having. But if we are filtering based on a column that already exists in our database, we use the where clause.
All right, I get that.
Okay, so so please let's proceed. So I believe this the assignment is clear to everybody now. Now I'm going to what we have today. What is a database? A database is simply an organized way of storing, managing, and data so it can be easily accessible. Now, why do we store information on a database? Information is stored so it can be easily accessed. So it can be easily accessed by anybody, anywhere, wherever the person is. Database also gives us a functionality of organizing our data properly so that we can easily manage it wherever we are, and according to our business requirements. Now we have two major types of databases, which are the relational database and the non-relational database. A relational database is a database that uses a fixed structure to save data. A relational database uses tables to store data, while a non-relational database is a flexible way of storing unstructured data in a database. That's basically the difference. The relational database uses a fixed structure. So if we want to store data and it comes in rows and columns, that's when we make use of a relational database. But if our data comes in say a bulk of text and we want to store it, or it comes like in a JSON format, that's where we store it in a non-relational database. And examples of this database are, for a relational database, we have the PostgreSQL, we have the MySQL, we have SQL Server. Then for non-relational database, we have the MongoDB, Cassandra, and others. So now, for the relational database, the relational database, it has some key attributes. And some of the key attributes of a relational database, next please, is it has tables, it has keys, and it has relationships. Now, what does the tables do? In a relational database, data is actually stored in a table, and a table is made up of rows and columns. Now, these rows can be referred to as records, while the columns can be referred to as fields. Then we talk of keys. Keys are used to define relationship between tables in a database. A database usually contains more than one table. A database contains more than one table. So for these tables to pass data and communicate with each other, for them to interact with each other easily, we make use of keys to create a relationship between these tables. Then we're also talking about relationships. There are different types of relationships between tables in a database, and they are one-to-one, one-to-many, and many-to-many. All of this, we are going to break it down one after the other as we go on. Now, looking at in the diagram, we can see the diagram of a database which contains two tables, and each table is made up of rows and columns. Then we're talking of keys. There are different types of keys in a relational database. Next, please. Now we have the primary key, which is used to identify each row in a database uniquely. Now, for the aim of using a primary key is so that when we want to identify a record or a row in our database, we use the primary key to identify that record. Without the primary key, we cannot bring out a record. We cannot bring out a record, or we'll bring out conflicting records. So the aim of a primary key is to uniquely identify each record in our table, so that when we need that record, we can identify it easily using the primary key. Then the candidate key is a column that can be used as a primary key. Now, what this means is, take, for example, a table, let's say a student's table. Now, a student's table has three columns. The first is the student ID. We have the student's name and then the email address. In a table like this, there are two columns that can actually be used to identify a student. And these columns are the student ID, because every student has a unique ID. And we also have the student's email. Every student's email is also unique and is used to identify each student. So in a table like this, where we have two columns that can be used as a primary key, if we choose one to be the primary key, the other becomes the candidate key. So if we decide to use the student ID as the primary key, the email address, the student's email, becomes the candidate key for that table. Then we're talking of foreign keys. A foreign key is used to link two tables. Now, a foreign key in table A is the primary key of table B. A foreign key is used between these two tables to identify and get information between two of them. So a primary key in one table can be a foreign key in another table, because that key will be used to combine both tables in case we need information, or we want to query a database on those two tables. Then we have the composite key. A composite key is a combination of multiple columns to form a primary key. Take, for example, we have a table that has, let's say, a enrollment table. Okay, yeah, we have something like that. So let's say, for example, we have an enrollment table. Now, this enrollment table contains a student ID to identify a student, which is the primary key for a student's table. And it also has a course ID to identify a course. Now, these two columns, that's the student ID and the course ID, they are both foreign keys in the enrollment table, though they are primary keys in both the students and the course table. But coming to the enrollment table, they are foreign keys. Now, being that we have two foreign keys like that can be used to identify each student in the enrollment table, those two keys combined together are known as the composite key. So a key is actually used to maintain integrity and to show relationship between tables in a database. Then we talk of relationships. Whenever we mention whenever we talk of relational databases, we talk of relationships. Now, there are different types of relationships, like was mentioned, and the first one here is a one-to-one relationship. A one-to-one relationship is a relationship such that a value in or a record in table 1 uniquely identifies another record in table 2. Now, what this means is that one record in table 1 is directly related to just one record in table B, and one record in table B is also directly related to one record in table A. So, for example, we have two tables. One is the capital letters of the alphabets, capital letter A to Z. And the second table, we have the lowercase letters for A to Z. Now, if we look at these tables, we will see that there is just one-to-one relationship exists between these two tables, because capital letter A from table 1 is related only to small letter A in table 2. Capital letter B in table 1 is related to only small letter B in table 2. So when we look at that kind of relationship, we say it's a one-to-one relationship. Excuse me, please. Then underneath it is a representation of how it is shown whenever we're drawing an entity relationship diagram. That will also be addressed later. Now, there are different ways of showing a one-to-one, one-to-many, and many-to-many relationship. But the one showing here is the most common means of identifying this one-to-one relationship, and it's known as the Krause-Foot method. So this is the most common means of identifying a one-to-one relationship between tables. Then we go to one-to-many relationship. This means for a one-to-many relationship, it means that one record in table A is related to many records in table B, whereas one record in table B is related to just one record in table A. I'll take that again. One-to-many relationship is that in table A, one record is related to multiple records in table B, whereas from table B, one record is related to just one record in table A. So that gives us a one-to-many relationship. Now, let's, using as an example, we'll talk of customers and orders they place. Yes, that should go. So yes, a customer can place so many orders. If we have two tables, a customer's table and the orders table, you see that a customer can place so many orders, but an order can be placed by just one customer. So that shows a one-to-many relationship between a customer and the orders table. Next, we'll go to many-to-many relationship. Now, this one is the opposite of a one-to-one relationship. It tells us that one record in column A is related to multiple records in column B, in table B. Also, one record in table B is related to multiple records in table A. Now, we're going to give an example using students and the number of subjects or courses that they can take in an institution. One student, if table A is the students table and table B is the courses table that we're expected to enroll in the university, you will see that one student can take multiple courses, and one course can also be taken by multiple students. So in such a situation, we'll say a many-to-many relationship exists between these two tables. Now, the representation beneath is also how it is being represented in our ERD diagram. Then next, we're looking at data normalization. Next, we're looking at data normalization. Data normalization is simply how we organize data in a database. Now, the aim of data normalization is to reduce repetition, repetition of data and to improve our data integrity. Data normalization is used so that we do not have repeated values or repeated records or information in our data. It also helps us break down the tables in our database to smaller and better units that can be managed. So in the situations where we get to update or delete or insert newer values in our database or in our tables, we do not get to so for example, we want to update an information on our database. We do not get to update everything on our database. No, we just check the needed table and we update just that table. So data normalization helps us break down our tables, the tables in our database, so that we will have smaller units and to avoid data repetition. Now, there are three forms of data normalization. We have the first formal form, we have the second normal form, and then we have the third normal form. Now, before we look at these three forms with examples, let us first of all see what in an unnormalized table looks like. So an unnormalized table is a table that contains like every attribute, all the columns that we want to create. We decided to put everything in one table. That is an unnormalized table. Although it depends on what we need, but when we're talking of building a database, rather than breaking these our tables down into smaller units, we've decided to put everything into one table. If you look at that table, well, you see that that is an unnormalized table. Now, looking at the example we have here, we have the user ID, the name, email, and course name. If we look at the user ID, yes, everything seems to be in order. The name also, everything seems to be in order. Coming to the email address, it all looks to be in order. But when you look at the course name, you see that there are some columns, there are some records that are separated with a comma. Now check the person with user ID 1. If you look at his course name, there are 2 courses there actually. So that shows that our table is unnormalized. So for us to normalize it, we need to break down our course name so that every course will be on a row of its own. So every information will be a record on its own in our database. And that takes us to the first normal form. Now, in the first normal form, every information, every column of our database, they are in their lowest atomic unit. Now, this means that it's not separated by commas as was seen in the previous example. So for that example to be in its first normal form, we have to remove the comma and put all those information in as a different record on the table. So looking at our first normal form, we have that Omoema with user ID 1 has 2 records because he is registered in 2 courses. We also have that Okoronkwo with user ID 2 has 2 records in our database because he's registered on 2 courses. So looking at all the columns in this database, you will see that they are all in their lowest units. So that's what makes this table in its first normal form. Then we go to the second normal form. Now, if we look at the table, if we look at table 1 again, you find out that the course name is not actually dependent on the user ID. Now, what this means is that our course name can actually be an independent unit on its own. A course is different, totally different from the students. So without students, student 1 or 2, our course will still exist. So the courses are actually independent of the students. And since that is what is attainable, we will have to remove the course name. We will have to remove the course name from this from the first normal form and put it in a separate table, making it in its second normal form. So in our second normal form, we remove every information or every column that has no that is not dependent on the primary key of our main table. So as it is now, the courses are not dependent on the students. They can actually stand alone. So breaking that down gives us our data in the second normal form. Then we'll go to our third normal form. In our third normal form, we now look at the second, the course table. If you look at it, you see that both the user ID and the course name, they are actually repeating itself. And this tells us that the relationship between the courses and the student is actually a many-to-many relationship. In such situations, to break it down to its best and best normal form, we need to create a third table, which is known as the junction table or the bridge table. Now, this table will take the primary key of table 1, which is the students table, also the primary key of table 2, which is the course table, and create a different table on its own. So looking at this third normal form, we now have that the student's information is different, our course information is different. Now, rather than having about six rows in our course table, we now have just 3 because we have only 3 unique courses on our table. Then we now have a third table which contains the user ID and the course ID. Now, this makes the table easier and better to manage, easier to update, easier to perform queries, and better to manage generally. Then we'll now come to data modeling. What is data modeling? Data modeling is a structured way of defining what data will be stored in our database, how the data will be stored, and how it is related. Now, when we talk of data modeling, what we use to model our data are ERDs. And ERDs are simply known as entity relational diagrams. These diagrams help us to model our data. It's like you're building a house. Before you start laying your foundation or building the house, you need to consult an architect to draw out a plan for you before you start building. So data modeling is us consulting an architect to draw up the model of our data, to tell us how we are going to structure our data before we start building. So in this situation, we used ERDs, that's entity relational diagrams, to model our data after taking into consideration the keys, the normal forms, and other things that we have discussed previously. Now, if we talk of the components of an entity relational diagram, we're talking of entities, we're talking attributes, and we're talking relationships. Now, what are entities? Entities are simply what data will be stored. Entities gives us a breakdown of the type of data that will be stored in the database. Attributes are what will be in our entities. Now, if we're looking at a database generally, an entity is also the tables in our database. While when we say attributes, attributes refers to the columns in our database, the columns of our table, sorry. So entities refers to the tables, while attributes refer to the columns in each table. Then relationships talk of the kind of relationship that exists between two or more tables in our database. Then going to database design is simply designing our data according to how it is modeled. Now, database design is after collecting our plan, the building plan from an architect, we now start digging the ground, laying foundation, and building according to the plans given to us by the architect. So after writing out, after modeling our data using the entity relational diagram, data modeling is where we now come to our database and start writing queries to create the tables, the columns, and the relationships as drawn or as presented in our data model. Now, whenever we want to design a database, there are some things we should actually take note of, which are using of table names. We use names that are actually meaningful and names that reflect what the table is used for. We cannot have a table that contains information about students and we'll write the table name as say doctor's table. Unless the table contains information about doctors, then we can give the table name as doctor's table. But when we're naming our tables, name them according to the information that is contained in that table, as it makes this the design easier and it makes working with the database easier. Same goes for the column names. When you want to put in your column names, if it's something we want to use as a primary key, for example, say user ID, instead of user ID, using a user ID as our primary key, we decided to say write address, whereas the content of that column is not addresses, but unique keys used to identify each record in the table. So whenever we're naming our tables, columns in our database, we need to be mindful of the kind of names that we give to them, so that whenever we are using it in our queries, we are not confused and it's easier to query. Then in designing our database, we should also identify the entities and always clearly define our keys. Definition of keys is stating in your database which key is the primary key and which is the foreign key. Now, as someone who knows, who has information and who is knowledgeable about databases, you can actually look at the database schema and know which is a primary key or a foreign key in a table. However, it doesn't mean that it should not be stated when you're designing the database. State which key is it, so as to avoid so as for the purpose of clarity and to avoid confusion. State and identify the primary keys, the foreign keys, and the surrogate, the composite keys, and other keys that define relationships between your tables. Then schema documentation. Like I said, anything that you're doing in your database, always make sure that you write comments so that when you leave it today and come back to it tomorrow, you would see clearly what it does. You will clearly look at it and just read the comments, and you already know what the function of a certain query or a a query or a table creation. You already know what that query does. So comment out your queries, document your schema, and even if you do not read it tomorrow, somebody else comes back, the person just has to read it and he or she would understand what you're doing. Then also plan for growth. Whenever we're designing databases, designing tables like this, it's always good to plan for growth, in the sense that we we design databases that are scalable. This means that at present, probably we have only 50 users in a company. We are working for an organization and we have just 50 users. So we define our schema strictly for 50 users. In planning for growth, we take into consideration that someday soon we are going to be above 50 in this organization. So we do not constrict our database to cater for only 50 employees. We include space for growth, so that if we add a new person, if we become 51 tomorrow, it is not a problem with our schema. Our schema can actually easily receive the record without failing or giving us errors. So, all right. So next, this is what I wanted us to do live. I wanted us to create this entity relational diagram, to work on it together. I wanted us to work on this entity relational diagram together. We'll create the tables. The relationships are already defined. Now, from the students to the enrollment table, we have a one-to-many relationship there. Also, from the course to the enrollment, we also have a one-to-many relationship. So I wanted us to look at this live and see how these relationships are being applied when we are writing our database, when we are creating or designing our database. But I don't think that will be possible today. Anyway, I'll ensure we'll work on this next week. Please, you all should bear with me for today. I'll see how I can do to make some changes and ensure that from next week we'll be working live. Then lastly, all of these things that we have finally discussed, all these things that we've been discussing, relational databases, database design, schemas, normalization, and the rest of them, how does it concern a data engineer? Now, the role of a data engineer in all of this is to ensure that data moves from a source to a destination without breakdown. And the destination we often work with is actually in our databases, either a database or a data warehouse. That is usually the storage destination. So it's important that while this database is being designed by developers, the data engineer collaborates with them to define structures of entities and the relationships. Now, giving an example, without the input of a data engineer in designing a database, a developer can do what he or she likes. And when it's time to create the pipeline that will ingest data from a certain source into our database, the pipeline would likely fail because the schema of our database was not designed properly to handle the type of data that is coming in from our source. It could be a mistake or a misspelling in handling of data types. So someone could design a database and a table, for example, a table that should contain name is being written as an integer data type. It's written as an integer data type in our schema. Then when it's time to ingest our data, that data will not enter our database because it cannot read a string data type from our source and put it in an integer data type in our database. So it's important that when developers are designing the database, a data engineer is always there to assist in defining the data entities and their relationship, and in defining the data entities, their relationships, and for us to understand the various data types and the various data constraints that would likely make the data pipeline to fail. Also, all of this is to ensure data integrity and also to ensure data scalability. Like I explained before, it's a situation where instead we are not constricted to just a few numbers or a few we are not constricted to a fixed number of say rows in a database. Now we can also look at an example of still a column that has to do with name, a name column. Now this name column was actually declared rightly as a character, but it was written that it will accept say only 5 strings. It is going to accept only 5 characters, while this was the definition in the database schema. Now we're ingesting data from our source, and the column that is put to accept just 5 characters, that is someone imputes a name that is as long as say 10 characters. When that data is coming into our database, it will give us an error because the string that was defined in our database is supposed to get only at most 5 characters, whereas what is coming in is coming in with 11 characters. So at that point, our pipeline will fail and every other information that we'll need will not run. So it's important that as a data engineer, you understand how data is being stored, how data is being managed, and how it is being designed in a database, so that when writing your pipelines, when creating your pipelines, you ensure that your data moves from source down to the destination, which is your storage unit. It flows and moves easily without disruptions. So I guess that will be the end of today's class. And so this should be the end of today's class. If there is any question, please let me know. Okay, sorry, attendance. Sorry. So does anyone have any question, please? Okay, so it looks like nobody has any question. Let me look for the attendance and send it. Oh. Okay, so I've sent the attendance in Ibrahim, thank you very much. Thank you very much. I really apologize for all of this. I'll see how to make sure that I make changes by next week. So thank you for helping us out once again today, Ibrahim. Now we have two persons raising their hands. So Kosim and Ayoluwa. Kosim, please let's hear from you.
All right, I just wanted to ask what your definition of data schemas are. Because
Sorry?
when I was, your definition of data schemas, like what's your definition? What are data schemas?
Okay. Now data schema is actually creating a database. It's the queries used to create tables and columns in the database. Did you get?
Yeah. That's just my question.
Is that all?
Yes. No.
Okay, so it's just the queries used to execute our data model. Those queries that we use to create our tables, insert rows in our tables and the rest of them. That is the schema of the database. It's just the structure of how our data is being stored in the database. Sorry. Ayoluwa, let's hear from you, please.
Yes, thank you very much, Ogochukwu, for today's teaching. But I kind of missed your explanation around the normalization, like different levels of normalization. I would appreciate if you can just brush through that again, like the first normal form, second normal form, and you explained.
Okay, so normalization in a database, the main aim is to help
Your
us read.
audio is bad. I don't know.
Sorry?
Your audio is bad.
Again, sorry, my throat is spinning me already. So normalization in a database is of data, and to ensure that our data is properly saved so that when we need to manage it, we can manage it properly. And not just that, we're looking at especially when we want to update or change certain things in our database. A situation where we have one table in our database, and the table contains, let's say, 15 columns. Now for you to impute sorry now for you to update or do anything on that table, you have to do it on all 15 columns. Now data normalization tells us that there is a better way we can organize our tables in our database, we can organize our data by breaking down the information into different tables. So instead of having 15 columns in one table, we can break this information down such that we have just maybe 3, 5 columns in one table. Now, the first normal form is that the table, in a table, though there are certain information that are repeated in that table, but every column is in its lowest form. Every column is in its lowest form, in its atomic form. That's that's what a database table being in its first normal form means. Now, being in its second normal form, it means that every information on that table does not have any dependency. Now, if we have a table, okay, like the example that we gave, we have students' information and courses information on one table. If you look at it very well, you will see that the student information can actually be handled differently from the information about the courses on our database, on that table. So that table is in its first normal form because there are still dependencies, because there are no dependencies in that table. So the courses can actually be independent of the student's information from that table. So when we separate both the courses and the student's information into different tables, that's when it comes to its second normal form. Now, in its second normal form, every table is independent of its information. Every information on each table is dependent of themselves. They do not depend on another table to get their information, or records. Then when we talk of the third normal form means that there is no form of dependency again exists. Now, if we look at the course and the students table that we used to give us as an example, despite separating the courses from the students, you will still see that in that courses table there is too much repetition, because one student has taken 2 courses. There is repetition of that student and the 2 courses that he or she has taken, such that there is repetition in the student's information and also in the course information on that courses table. So third normal form tells us that this courses table, we need to further break it down so that the main focus of that table, which is the courses, will not be repeated. So in the third normal form, we now go to the courses table and remove every form of repetition on that table and put it in a third table to hold that relationship, while the second table now has singular information concerning our courses and only the courses itself. Then we come to the third table and then create the relationship between the first table and the second table, which is the students table and the courses table. So when we look at the third normal form, all of our tables are in their list units, with none depending on any information, except the third table which we created, which is also called the junction or the bridge table. That table now contains information concerning the connectedness between the 2 tables on our database. So the other two tables, there is no form of repetition because they are created based on their individual units. The students table is created to handle information of just students, while the courses table is created to handle information of just courses. Then the third table, which we created, now handles the combination of both the students and the courses. So in this situation, if we want to make any changes whatsoever, we don't even need to go to the third table. If we want to make changes on our courses table, we go to our course the course table directly, make the changes, and it will actually be reflected in the other table, the third table which we have created. So we do not need to go to other tables when we want to make updates, deletions, or when we are querying or when sorry, when we want to make updates, deletions, or any other or want to do any other want to manage a database table in any other means. So making it in the third normal form gives us that this is the best form with which we can present our tables in the database, such that every main information has its own table, and the connectedness of these two tables are actually placed in a third table known as the junction or the bridge table. Did you get that, Ayolua? The attendance, hold on, please. Please, I need someone to confirm. Is the attendance going? Someone said it's not clicking. Okay. Please, Onome, try back. Try again. So Ayolua has left. Okay, thank you. Please try back, Onome. I guess it should be from your end since others are reporting something different. So I hope that's clear. If we do not, does any other person have a question? None. Okay, so next, immediately after this call, I'll be giving our assignments for this week. And this week we'll be looking at data warehousing concepts and an introduction to Snowflake SQL. Snowflake is another form of SQL that is being used in a data warehouse. So we'll be looking at using how to use Snowflake SQL to interact with data warehouses next week. Then also I'll be assigning 5,000 XPs to everybody. Now I noticed that some persons actually stay ahead of our class, and most have completed these courses before it's been assigned to them. Now, if you fall into that category and you're given XPs to earn, you'll find out that even if you repeat the courses that we've assigned to you, you will not earn the XPs that is assigned to those courses. Now, so henceforth, I'll be giving attendance. So henceforth, I'll be giving a minimum of 5,000 minimum of 5,000 XPs. So henceforth, we'll be given a minimum of 5,000 XPs so that you can practice and attempt questions on data camp. You can do practice of the things that you have learned so that you will achieve this 5,000 XPs. Now, the aim of this is by 2 months, so as to ensure that at the 2 months mark, we all earn a minimum of 50,000 XPs. That's what we are trying to achieve here. So for those that have gone ahead of class, please don't stop. You just have to earn your XPs another way. But those that are with us in this class that haven't completed this week's assignment, when they're assigned to you, you can study and earn the normal XPs. But for those that have actually done before, please, you have to earn your own XPs by interacting on data camp, not by learning our courses, but in other means. You have to practice and do some other projects and assessments, so you earn the XPs. And at the end of 2 months, everybody here must have earned the minimum XPs, which is 50,000. So I'll be sending out the assignments immediately after this class. So please, for those that are learning and those that have been consistent, I really appreciate. I appreciate how you've been going so far, and I appreciate how you've been learning. Please don't stop. Don't stop. So that when the time comes, you won't even be thinking if your scholarship will be revoked or not. You know that you have skilled, and not just that, you learn and understand what you're learning when we come to sessions like this and have just a recap. So thank you very much for today. Okay, someone asked, please, you can send me a DM on Discord. Carolia, please, if you're on Discord, you can send me a DM. I'm reachable there. So thank you for today, and if that's all, that will be good night from my side here. My ID on Discord. Thank you very much, Ayoluwa. Okay, on Discord, I am at Favor. Let me type that out. Okay, so you can reach me there. You can send me a DM on Discord. All right, thank you very much, and enjoy the rest of your evening.
Bye.
Thank you.
Bye.
Good night.
Good night, everyone. Good night.
know their interests, and they will build on that interest to like identify what everybody would benefit from, and then we work on it. Even though I have my own interests, I would like my interests